So welcome to this latest video on 162 Maths, and in this video we'll be going over the GCSE AS Maths topic of coordinate geometry with the focus of finding the equation of a perpendicular bisector between two given coordinates. Now, finding the equation of a perpendicular bisector between 2 points is exactly what it says on the tin. Now, if you think back to when you did loci and you're trying to find the perpendicular bisector or draw the perpendicular bisector between 2 points, in this particular example, what we're doing is finding the equation of that straight line. Now, if we think back to what a perpendicular bisector is, so if I just take this point here and just call this A, and this point here being B. Now, if I was to draw a line that connects those 2 points and a straight line as such like so, then the perpendicular bisector will not only go through the midpoint of AB, but also will be perpendicular to that line that joins A and B, and there that gives us our perpendicular bisector, which is this red line here. And B. Now, in order to find the equation of that red line, we need to know a gradient and we need to know a coordinate. Now, the gradient, as we've already mentioned, is going to be perpendicular to the line AB, and the coordinate is going to be going through the midpoint of A and B. So to find the equation, all we need to do is follow these 4 steps. Now, in terms of the first step, it's finding the midpoint between the 2 points, in which all we need to do is use the formula to find out the midpoint between 2 points, which is x1 plus x2 divided by 2 and y2 plus y2 over 2. And this will give us our x and y1 values that we're going to later use for the equation of a line. The next thing we then need to do is to find the gradient of the 2 points, in which we use this formula here of y2 minus y1 over x2 over x1. In other words, the difference in y over the difference in x. And then because we're trying to find the equation of the perpendicular bisector, it's going to be the negative reciprocal of that gradient that I've just highlighted. So these 2 steps here is going to give me the gradient of the perpendicular bisector, and this point here is going to give me the coordinate. And once I've got those 2 things, all I then need to do is use the equation of a straight line and substitute those 2 values into the formula. So now let's have a look at some example questions. So in this question, we're asked to find the equation of the perpendicular bisector of the straight line that passes through, and we've got our set of coordinates. So if we look at question 1, so here what we want to do is find the midpoint. So to find the midpoint, we add the 2 x ordinates and divide that by 2. We then add the 2 y ordinates and divide by 2. So here I've got 8 divided by 2, which is 4, and 4 divided by 2, which is 2. Then what I then need to do is find the gradient. And so here I'm going to have minus 1, or minus, I should say, got the wrong coordinate there, so let me just correct that. And here we're going to have 4, 6, and we've got 2, 0. So from this we get our coordinate of 4 over 4, which is 1. And then we need to do the negative reciprocal of that, which gives me an answer of minus 1 over 1, which gives me a gradient of minus 1. So then finding the equation, it's using these 2 bits of information here, in which what I end up with is y minus 2 equals minus 1 x minus 4. Now, you could leave your equation like this, or you can try and simplify to make y the subject. So here I've got y minus 2 equals minus x plus 4, which then becomes y minus x. Don't worry, I've got 2 there. And then plus 6. So that's one variation we could have. Or you can write x plus y minus 6 equals 0. Any formation of that would be absolutely fine. Then if I move to my second question, so here to find the midpoint, I add the two x ordinates. So I've got 2 plus 4 over 2. Add the two y ordinates together. So I've got minus 5 plus minus 1 over 2, in which I get 3, and that's going to be minus 3 as my coordinate. The gradient is going to be minus 1, 4, and minus 5, 2. And I'll take those away. So just be mindful when you have got negative ordinates, just to make sure you're not messed up on your negatives. So here that's going to turn it to a plus. So I'm going to end up with 4 over 2. And that gives me an answer of 2. So therefore, my m value of the perpendicular bisector is going to be minus a half. So then using this coordinate and this gradient, I can then work out what the equation is going to be. So it's going to be y plus 3 equals minus a half x plus minus 3. And then it's a case of what you then do with this. So we'll expand the bracket. So we get minus a half x plus 3 over 2. And then it's just a case of needing. Now at this stage, what you could do, if you're not comfortable working with fractions, you can multiply the 2. So I get 2y plus 6 equals minus x plus 3. And then just neaten it all up. So I get 2y plus x, and that's going to be plus 3 equals 0. So now let's have a look at example 3. So to find the midpoint, we add the two x ordinates. So I've got 3 plus minus 4 over 2, and I'm going to end up with 2 plus 1 over 2. So this is going to give me minus 1 over 2, and it's going to give me 3 over 2 as my coordinate. Then to find the gradient, we've got 1 minus 4, and we've got 2, 3. Take away the 2, in which we end up with minus 1 over minus 7, which gives me positive 7th. So therefore my m value is going to be the negative reciprocal of a 7th, which is minus 7. So then using this coordinate here and my m value, it's then just a case of substituting it into the equation of a straight line. So here what we've got is y minus 3 over 2 equals minus 7 x plus a half. Now from this, what I would recommend that you do is expand the bracket, and we're going to get minus 7 over 2, and then if we multiply everything by 2, we get 2y minus 3 equals minus 14x minus 7. And then if we neaten that all up, we get 2y plus 14x and plus 4 equals 0. And there is our answer for question 3. And I've just noticed that we can then divide everything by 2, in which we get 1y plus 7x plus 2 equals 0. And then you can then, if you want to write it in terms of y, we get y minus 7x minus 2. Now if you want to try a question 4, which has got a coordinate of minus 1, 4 and 3, 3, if you want to pause the video, have a go at it, and then unpause so you can see what the answer is. Well, the answer for question 4 you should have is 2y minus 8x plus 1 equals 0. And again, different variations of you could have are 2y equals 8x minus 1, or you could have y equals 4x minus a half. So any formation of those equations would be absolutely fine. So now let's have a look at a contextual past exam question. So in this particular question it says find the equation of a straight line P, which is the perpendicular bisector to the points 1, 2 and 5, 4. The line P meets the x-axis at A and the y-axis at B. Calculate the area of triangle OAB. Now this question may seem like it's only one question, but there's actually multiple things that we need to do before finding the answer. But we can't just simply race to the final answer. There are lots of subparts that we also need to find. Now the first thing we need to do is to find the equation of the perpendicular bisector, which in this case is called P. So if I just do a little sketch now, to get an understanding about what it is with these particular questions, if it's not supported with a diagram, I would always recommend drawing a diagram. So if I just do a little sketch of a set of axes, now 1, 2 I'm just going to say is here, and 5, 4 I'm going to say is here. Now the perpendicular bisector I'm going to say is going to be somewhere like this line here, in which this point here is A, where it crosses, no actually that is B. This point here is A, and this point here is B, and the O is the origin. So what the last part of this question is asking me to do is to find the area of this triangle. Now in order to find that, I need to find those coordinates where it crosses the axis, and in order to find that I need the equation of that line AB. So to find the perpendicular bisector, so the equation of AB. So the first thing we do is find the midpoint, in which that's going to be 1 plus 5 over 2 and 4 plus 2 over 2, which is going to give me a coordinate of 3 and 3, 3. And then I need to find the gradient of those 2 points. So it's going to be 4, 5 and 2, 1, in which we get an answer of 2 over 4, and that's going to give me a half. So M is going to be the negative reciprocal of that, which is -2. So then using this coordinate and this gradient, we can then work out the line AB. So it's going to be y minus 3 equals -2 x minus 3, and neatening all this up, we get y minus 3 equals -2x plus 6, in which we get y equals -2x plus 9. Now to find the point AB, which is what I need, so for A, this is when y equals 0. So when y equals 0, I'm going to get an x value of 4.5. So that means that this coordinate here is at 4.5, and B is when x equals 0, and that gives me a y value of 9. So then to find the area of AOB, so the area of AOB is a triangle, and it's got a height of 9 and a base of 4.5. So to work out the area, it's the base times the height divided by 2, which gives me an answer of 20.25 square units, or 20 1/4, whichever floats your boat. Now moving on to our second contextual question, it says find the equation of the straight line P1, which is a perpendicular bisector of the coordinates A and B, and the equation of the line P2, which is a perpendicular bisector of B and C. And the question's also asking us to find or show that P1 is perpendicular to P2. So with this particular question, there's 3 things we need to do. So the first thing we need to do is to find P1. Then we need to find P2. And then what we need to do is show that P1 is perpendicular to P2. Now if I just get rid of the highlighting, just because I know it's a bit of a distraction from the question. So for this, let's find P1 first. So the gradient, or the midpoint I should say, is going to be 1 plus -2. over 2 and 3 plus minus 5 over 2, and that's going to give me a coordinate of minus a half and minus 1. And then finding the gradient between those 2 points, it's going to be minus 5, 1 and 3 and minus 2. Again, just be careful with the negatives. That gives me a gradient of minus 8 over 3. So therefore, the gradient of the perpendicular bisector is going to be the negative reciprocal of this. Now, if it's a fraction you're working out reciprocal, all we need to do is flip it and change the sign. So that's going to be plus 3/8. So then using these 2 bits of information, I can then work out the equation of P1. And just to save a bit of time, that equation we should have is going to be, and again, there's different variations we could have. So let's write y plus 1 equals 3/8 x plus a half. And neatening all that up, what we get is we get something along the lines of 8y plus 8 equals 3x plus, and that's going to be 1.5, and or 16 plus 16 equals 6x plus 3. So whichever you prefer, whichever equation you want, that's going to be my equation for P1. Then if we repeat the process for P2, so for P2 we get an equation of, we're finding the midpoint, we get a midpoint of 9 minus 2. We get a gradient between those 2 points of 1 minus minus 5 over 17 minus 1, and which we get a minus minus 1, that should be, is it? No, that's right. And that gives me a gradient of 6 over 16, which is 3 over 8. So the gradient of P2 is going to be a negative reciprocal of 3/8, which is minus 8 over 3. So then finding the equation of those 2 lines, using this and this, we get a P1 equation of y plus 2 equals minus 8/3 x minus 9, which can be written as 3y plus 6 equals minus 8x plus 72. Neatening all that up, if you wish, we get 3y plus 8x minus 66 equals 0. So not the nicest of equations, but there's our 2 equations. Now all we're interested in is the gradient. So if I return back to this equation here, the gradient is this, and for P1 the gradient is 3/8. So as 3/8 multiplied by minus 8 over 3 equals minus 1, P1 is perpendicular to P2. And there we go.